further. If you guys have any issues dealing with math, dealing with any other subject, personal issues, family issues, if a rock falls out of the sky and hits your house and goes through your bedroom and lands at the foot of your bed, any of those things happen, you can blame me. I will take full responsibility. Okay? So your tiredness, your sleepiness is total my responsibility. Okay? Alrighty, here's our theme song today. Oops, it disappeared on me. So let me turn up the volume a little bit. That's why I said you're wearing the appropriate shirt. Can you guys hear it okay? I gotta figure out why my speaker's not working. Let me try it again. Yeah, maybe my speaker's not. I gotta figure it out. Alrighty. By the Beatles, of course. From their Abbey Road album. Do you guys know who wrote that song? Do you guys know who the four Beatles are? Okay, John Lennon, Ringo Starr was the drummer, Paul McCartney, and George Harrison. And George Harrison wrote that song. He's one of the best guitarists ever. And he does guitar work. So, just a little trivia right there. Alrighty. We're doing notes, is that correct? Oh my God, I got paper like crazy. Let me get it all together. So we must be on and by the way, Aiden, all the notes and everything, 1, 2 is on Schoology, everything will be on today. Even the written notes part will be on today, okay? Or later this evening. Again, that's always depending upon if I have a job to do. Okay. So maybe but tomorrow. Where did I end up on this? Was I doing continuous functions of every point? Did I do tangent graph and we come up with intervals? What? We were doing the IVT. Okay. I'm going to come back to this one right here, and let's say I gave you this problem. Ooh, I don't want that pen. I want this one. Okay. First of all, I'm going to back up a little bit. Let's say on a quiz, I say we had the function h, and h is this. It is x squared plus 3x plus 2 over x squared minus 3x minus 4. And my question is, find the intervals of continuity. In other words, list the intervals in which you know the function is continuous. Denise, I'm not going to start with you. I'm going to start with Ty. Okay? Ty, where would you start? I agree. Now I'm going to give you, since it's Thursday, and Thursday is one of my favorite days of the week. I do not know why. My least favorite day is Sunday. I get stressed out on Sunday. And I don't know why. I love coming to school. But it's like, okay, I got this stuff I've put off all weekend. Now I got to deal with it. Okay? I'll factor one of them for you. Which one? But you got to do the other one. Which one do you want me to factor? Well, yeah, you got to decide.
The top one.
You want me to factor the top one? Oh, you're very kind. Two numbers that I multiply together that give me 2. are 1 and 2. Boom, I'm done. Now you got to factor the bottom for me.
X minus 4 and x plus 1.
X minus 4 and x plus 1. And Landry, am I pleased? Am I excited to see this?
Yes.
Yes. Why?
Because the x plus 1 is the divided.
Right. In other words, I can take my red pen and do a little slash, right? Okay. So, Julia, do I have, notice it says continuous at every point in their domain. Do I have numbers that are not in the domain of this function? Did you say yes?
Yeah.
Yes. Can you name one of those numbers? 4 I'm not allowed to use, correct? Because that would give me discontinuity, correct? Specifically, what type of discontinuity, Julia? What would it look like on a graph? Would it be a hole? Don't know. I'm glad I asked the question, okay? Owen, what would it be? I agree. How would I show that on a graph? Right, it'd be an asymptote, okay? Because it still remains there. I wasn't able to remove it. Okay? So, Elijah, right here at x equals a negative 1. Do I have a discontinuity there? Yes, you do. You got to remember my original, I can't put a negative 1 in here, can I? I'd have 1 plus 3 minus 4. I'd have 0 in there, wouldn't I? But it's a removable discontinuity. I simplified it out, but it's still discontinuous at negative 1. So there are two values that are not in the domain. 4 and a negative 1. Everybody understand that? This one's a hole. This one's an asymptote. All right, Ryan. Give me the intervals of continuity. Going from where to where? Where is this continuous? Could I put a negative 1 million in there? Okay.
Negative infinity
To where?
to negative 1.
Negative 1. Beautiful. Because I got a problem there, right? And then I'm going to have from negative 1 to what?
4.
4, because I got another problem there. That's not in there, is it? And then from 4 to what?
Positive infinity.
Positive infinity. Now, you guys maybe last year saw that, hey, I got to put a union symbol in there. You don't have to do that for me. You might see that on a multiple choice on an AP exam. Just make sure you look for the correct intervals. Are we okay with that? Alrighty, intermediate value theorem. So what's going to happen here, I'm going to write the theorem. There are 3 important theorems in calculus. One's called the intermediate value theorem. That's the first one we learn. Then we learn the second one, which is called the extreme value theorem. And then we're going to learn the third, which is called the mean value theorem. And because there's 3 of them, students have a tendency to get them confused, and I'm going to try to do a better job teaching it. So what happens in AP, once you guys get the results, I get your results like a day before, so I already know how you did. And then about a few weeks later, I get the results, and I find out how I did in teaching, what you guys did well on the test and what you did not do well on the test. And one of the things I did not do well was try to teach the intermediate value theorem. There was a number of questions on the intermediate value theorem on last year's test. So I'm changing it and trying to do a better job, okay? So here's what the intermediate value theorem, the whole focus is on continuity. On a function being continuous. So it starts out, and I wrote down big idea, right? Big idea here. If f is continuous, that's the first thing that's stated. So when you state your explanation or your justification, you need to say that you know this function is continuous and why you know it's continuous, okay? So f is continuous. F is continuous on this interval from A to B. Now it may be closed, it may be opened, but some type of interval. And f of A is not equal to f of B. So what that is saying, I'm going to back up a little bit. And Aiden, I think you can answer this. A is an x value, right? Or an input value. But either way, they're the same thing, correct? And you're going to plug it into the function, correct? And you're going to do some type of math. And something's going to pop out, correct? So f of A is a what kind of value? If A is an x value, f of A is it's an output, which you are perfectly correct. What's another name for output? Okay. Do you think you know, Justin? Another name for output? If A and B are x values, and I plug them in, what kind of values come out? They're y values, right? Okay. It means one y, if they're not equal, it means one point's higher than the other point. Would you agree? So as I go from A to B, I'm either going up or I'm going down. Would you agree with that? In some sense. Does that make sense? That's why it's in there. Okay, where k, so you're going to have this k value, where k is between f of A and f of B. So Allison, what kind of value is k? Is it an x value or is it a y value? So let's say this. Let's say I plug in A and I get 5. That's the y value I get when I plug A into F. I get 5. 5 is my output. So my point is 1 comma 5. And I plug in, okay, let's say 3. And I get 13. So k is between 5 and 13, correct? Right, everybody follow? When I get stuck tie, I pick numbers. See if it can make sense. So what kind of value is k? Yeah, this is a y value. If f is continuous on the interval a to b, and f of a does not equal f of b, where k is between f of a and f of b, there must exist a c in the interval a to b, where f of c equals k. So I'll draw you a picture. Here's A. Here's f of A. Here's B. Here's f of b, and I'm going to make this a little bigger. I don't know if that's big enough. Justin, can you see that okay?
Yeah.
Okay. And I've got a k here. It's a y value, so these are all on the y-axis, aren't they? Correct? If they're y values, they got to exist on the y-axis. So k is somewhere between f of a and f of b, somewhere right there. So if I go over here, there must be a number that gave me k. That number is c, and this is f. So when I take c, plug it into f, I had to get k. And that c had to be between a and b. It had to be. Okay. So let's take a look at this. So this is how I'm going to show. Here's problem number 1. First thing I'm going to do, my first step, is to identify what A is. It says use the IVT, use the intermediate value theorem. Now, you can use the letters IVT on AP. And I do it because, Caitlin, I can't spell intermediate. And here's what I know about my personality. First, it takes me a long time to try to spell something. And intermediate has a lot of letters in it, at least in my brain. And I'll know when I spell it, I spelled it incorrectly. And I won't be able to let that go as I'm doing the entire test. And so 1, it slows me down, and 2, it doesn't allow me to focus because I'm focused on that stupid word intermediary. And so what I do is I always write IVT because I can spell I can spell V, and I can spell T. It's up to you what you want to do, but that's what I do. All right? So, Caitlin, what's A?
0.
Perfect. What's B?
1.
Now, there's a typo here, Denise, and I keep forgetting to tell you this every single time, and I keep forgetting to fix it on my notes. It's sad. It should be this. This plus should be a minus. So it should be x cubed plus 2x minus 1. Okay? So what's f of 0? It'd be -1. Perfect. Now, you don't have to show your work. You used your brain. You did arithmetic, correct? Does everybody see that? But I have to show this part. Does everybody understand? Or it might be so complicated that you had to use your calculator. You still don't have to show it. You could just do this. Does everybody follow that? I need to see what f of 0 is, though, what the value is. So what's f of 1, Caitlin?
2.
Yeah, it's 2. So this is what we know right now. If I were to plot this, here's 0, -1. Here's 1, 2, correct? Those are my 2 points, correct? X, Y, X, Y. And I know it's continuous. There are no breaks between those 2 spots. Notice that I curved it. You know why I curved it? Because I know it's not a straight line, right? It's not a line, it's a curve. Correct? Now, does anybody know what that is? What's a 0? What is it? Ah, awesome. X-intercept. Like this. Let me go to my machine. Where did I put my machine? A lot of x-intercepts, wouldn't you say? Here's an x-intercept, here's an x-intercept, here's an x-intercept, here's an x-intercept, here's an x. I see 6 x-intercepts. Would you agree? 6 zeros. Would you agree? What's another name for zeros and x-intercepts? Does anybody remember? Roots. Awesome. 6 roots. One more name. Yeah, I said x-intercepts. X-intercepts, roots, zeros, one more that I can think of. Solutions. Have you ever heard solutions? I used to have my students remember those 4. Okay? You guys are good that you remembered that. Okay? Now, notice this, Julia. None of them are 0. None of them is x0, correct? 0 would be right here, correct? None of them are. Yet, we call the x-intercepts zeros. Why do we call them zeros? What is 0? Y is 0, correct? So, k is equal to 0. K is a y value, k is 0. The biggest mistake that people made last year on this problem, because you'll see this kind of problem again, is they made x 0. It's not, is it? Y is 0. Now, we've done all our work. I'm going to say this. F is continuous since F is a what? Landry. I like saying the word Landry. Who's Dallas playing this weekend? Ooh, that could be a good game. That'd be nice to watch. I struggle sometimes. I'm not an Eagles fan, but I really hate Dallas. So anyway, so why is F continuous?
F is continuous.
Since F is a what?
Since F is a function.
But not all functions are continuous. Hence the step function, right?
F is a y.
F creates y values. F is a certain type of function. And I listed them right in here. You know if they're continuous, if they're this kind of function. So what kind of function is it? Starts with a P. It's a polynomial, since it is a polynomial. And 0, that's our k, correct? And it is between f of 1 and f of 0, correct? Right? So, there is a C in what? Here's 0, here's 1. That little doodad right there is C. What is C between? 0 and 1, right? Between A and B? In 0 to 1 by O's. Cross it out. So there is a C in 0 to 1 where f of c equals 0 by IVT. That's my explanation. That's my justification. I've got continuity. I got y is continuous. I look at my y values. So I say there's got to be a c within the interval they gave me where it has to equal that k. And then I ended up by saying by IVT. All right? If you turn your notes to the back side, it should be blank. Am I right? And this is what we're going to write as soon as I figure out where I wrote it. 1. Prove that there is a value C between 2 and 5 on f of x equals 3x squared minus 7, where f of c equals 40. Okay? Okay, here's our proof. Ty, what's the first thing I'm going to do? Identify what and what.
A and B.
What is A?
3. 2.
Okay.
2.
You're just trying to make me feel good by saying 3, right? Okay. Thank you. It just kind of made me feel cool. Okay. And what's B?
5.
5. That's the first thing you're going to do. Those are x values, correct? Because C is between them. So, Owen, what am I going to do with 2? You're going to put it in the function. And what am I going to get as an answer? No. This is when we use our brain. 2 squared. Oh, you were turning it off. Yes, very good. And I was wrong. You did not want to be tempted by an on machine. Yes. Yes. I had to do it in my head, even though I wrote it down. Okay. What's f of 5? 668 is correct, right? 5 squared is 25, 3/4 is 75 cents, take away 7 pennies, and I got 68 cents. 50-cent piece, a dime, a nickel, and 3 pennies. Okay. Alrighty, so we got that done. Okay. Elijah, ready? What are we going to say? We're almost done with our proof. We just need our conclusion. We're going to start with what letter of the alphabet? F is what? Since. What reason? And what am I going to say? Well, what is my K here? I guess I didn't identify what my K was. This is K, correct? And I want K to be between what 2 numbers? 5 and 68. And so 68 is f of 5, and 5 is f of 2, correct? Right? Would everybody agree? There, right? You're going to say that, right? There what? In what? The interval what? F of 2 is a y value and c is an x value. C is always x values. Between 2 and 5. Where what? Are we okay with that? A little easier the second time? Okay. Process is the same. Now, a lot of times in AP, they have a part A and a part B. You'll see that on the homework too. They might say this, find C. So if I plug C into that, I get 3c squared minus 7. Would you agree? And I know that has to equal 40. So I get 47 over 3 square root plus or minus equals c. Does everybody understand the math I did on that? I added 7, I divided by 3, I took the square root. It comes from the quadratic equation, so I should have 2, except negative is not between 2 and 5, is it? Correct? Right? It's gotta be, so this is what I do, Caitlin. There. And guess what? That's as much work as I do. Now, some of you may do this. You may go to your calculator and do that. You may go up here and what I did, see if I can show it to you. Well, maybe I didn't. I took 47, I divided it by 3, and then I took the square root. And I got 3.958114029. Okay, you got that? And you can do that too, except if you write 4, it'll be wrong. If you write 3.96, it will be wrong. You have to write 3.958. You have to go at least 3 decimal points or more if you have more than 3 decimals. Does everybody understand that? And they have to be rounded correctly. So there are people that like to see that. And one of the reasons I did do this was see that I came up with a number between 2 and 5, right? That's probably a good thing to see, that I didn't do something goofy. But I can get by and simply write that answer. Everybody cool on that? Which saves you a lot of time. All right, let's go to this one, which is this problem. Julia, I'm starting to get tired. And I wasn't up till 1:30 in the morning. I went to bed at 11:15. Okay, Denise, this is what AP likes to do. This was the question in 2007. It was number 3. Okay, and it had an A, B, and C, and I'm only showing you A, because you don't know how to do B and C, because I haven't taught it to you at all. Okay, but I'm going to show you some things. It gives you a table. They love giving tables. They love giving graphs. You don't know what the algebra is for those functions. Okay? And right now, if you notice, there's a column that has this little quotation mark, like F quotation mark, we call that F prime, and we call this G prime. It does not mean anything to you yet. It will in 2 weeks. So ignore it now. All right? Then the sentence says the functions f and g are differentiable for all real numbers, and g is strictly increasing. You don't care about that either, because you don't know what differentiable means, and you don't know why they're telling you it's increasing. Is everybody okay with that? It says the table above gives the values of their functions and their first derivatives. Again, I will teach you what a derivative is. The function h is given by this. So there's a function h. And it says f of g of x. That's a composition, correct? That means you put the y value of one function as the x value of the other function. Does everybody remember doing that with Mr. Karsh? Minus 6. Then it says this, explain why there must be an r value for the interval. 1 is less than r is less than 3. When you see an interval, it means you're going to do IVT. Such that h of r equals a negative 5. So Owen, excuse me, I'm going to pick Ryan. Is that okay, Owen? Okay. Ryan, what's A?
1,
What's B?
30,
What's K?
negative 5.
Negative 5. And K is a y value. So my next step is to get 2 y values, correct? I need to figure out what h of 1 is. Well, h of 1 is going to be f of g of 1 minus 6. So Aiden, what's g of 1? Two. Perfect. Minus 6. Since you're on a roll, what's f of 2? Yeah, 9. So I got 9 minus 6. I get h of 1 is equal to 3. Don't you think that's cool? 3. So Justin, next one I'm going to put in is 3. Would you agree? So that's f of g of 3 minus 6. Can you see that okay?
Yep.
So what's g of 3?
4,
And what's f of 4?
negative 1,
Negative 1 minus 6. So what's h of 3?
negative 7.
Negative 7. Our work is done. Now we're going to do the explain part. Denise, are you okay where those all came from?
Yeah.
Okay, because I know you're busy writing down, and I have a tendency to go too fast. So I'm going to slow down and just have a pleasant conversation to let you get caught up. Do you know your hair is a little reddish?
Yeah.
Has that always been the case?
No.
Did you dye your hair?
I used henna to dye my hair.
You use
over the summer.
henna?
Yeah.
Henna,
So-
is that the stuff that you write on your hands?
Yeah.
Really? I've never heard of that. Was that just an experiment, or have you heard of people doing that before?
No, I've heard of people doing it before.
Wow.
So I thought I would try it out for something.
And did you
different.
like it?
Yeah.
Okay, are you caught up with your notes?
Yeah.
Okay, good. All right. All right, so Allie, we got all the information, so I'm going to start out this way. And this is what you don't know, but you do know I need to say H is what? Continuous. Now this is the part you don't know. You will know in a couple weeks. H is continuous since F and G are differentiable. Now, I don't expect you to remember this at all. Differentiable means I can take the derivative of any point on that function, which I didn't tell the other class, but I'll tell you guys. When something's differentiable, it means you can compute the slope of the tangent line at any point on a function. That's all it means. Because you got an infinite number of points on a function, right? So you'd have an infinite number of tangent lines on a function. And if it's differentiable, you can figure out the slopes of all those tangent lines if you want. Okay. And anytime something's differentiable, guarantees it's continuous. You can't have a differentiable equation without it being continuous. The reverse is not true. You can have a continuous function that's not differentiable, but that's something, don't even worry about that right now. So anyway, we've got this. So our next step is to do what?
Say that H is a polynomial.
I don't know that. I just know it's, I don't even have to worry about, I said it was a polynomial because then that got me continuity. I'm already done with my continuous sentence. I'm done with talking about continuous.
Okay, so then negative 5 is in between 3 and negative 7.
You're almost correct. It's between, yeah, it's between negative, you're right. It's between 3 and negative 7, so I can write this. H of 3 and H of 1. Correct? You were correct. I was, and you could put a negative 7 here. Since I said negative 7 came from H of 3 and 3 came from H of 1, I can do that. But I usually write it in that form. So, Denise, there must be, now that I've got this negative 5 between these two y values, there must be what? And be careful, because they, do you know anything about baseball, Denise?
Yeah.
Okay. So they don't throw the same pitch, do they?
No, they don't.
No. You know why they don't throw the same pitch?
Use a different ball.
Well, okay, so do you know what a fastball is?
Yeah.
Okay.
I'm a softball player.
Okay. Oh, sorry, I didn't know that. So why doesn't the pitcher throw a fastball all the time?
To mix up the.
Yeah, why does the pitcher do that? Mix them up.
So that it's harder for them to hit off.
So the batter struggles, correct? Right? Well, AP does the same thing. They didn't throw you a fastball or a slow ball. They threw you a curveball. Here's where the curveball is. So there must be a what? And if you follow your notes, you'll say something, and it's not exactly correct. That's why they want to make sure you're a good reader. There must be a what, according to the notes, according to the theorem. There must be a C. But on this problem, they don't call it C. They called it something else. But if you called it C, they would mark it wrong. Because they'd say, C, I see no C. That was supposed to be bad humor, by the way. Okay? There's a what instead. What do they call C in this problem? R. There must be an R in what interval? Do you have siblings? Denise, do you have siblings? Do you have
Yeah.
brothers, sisters? Do you ever get angry at them?
Very.
Barry, do you ever raise your voice at them?
My sister.
Okay, pretend I'm your sister. My hearing aids aren't picking up very well today. So what is R in between 1 and 3? Where H of R, so when I plug R into H, I better get what is my answer. I want HR equal what?
-5.
-5. Okay? If you got that right, this would have been a 9-point problem. Every problem's worth 9 points. If you would have got that right, you would have gotten 3 points. To get a 5 on the AP exam, you want to get 6 points. You're halfway to 6. Because guess what? For the very first time, Justin, 3 years ago, somebody got a perfect. There's been one perfect person in 15 million attempts at this test. One. So they believe the majority of people will be imperfect. That's why they selected me to teach. They wanted somebody imperfect teaching, so you need to have a model of what imperfection looks like. Okay, does everybody understand that? You're not going to get, think about it. If you get 2/3, 67% correct, you're more than likely to get a 5. And what we've done, and by we I mean the entire teaching community, is said, no, you've got to be perfect. You've got to have 90. You've got to have 95. You've got to be 100. But when you take this test, no. That's not going to happen. Okay? But this is reasonable, isn't it? Now, there are some things you don't know. Differentiable. I got that part. You don't know what these columns mean. Those pertain to stuff that you're going to see next time. Okay? We'll get to them. All right? All right. Done with these notes.